This is to show us on how to be able to use Tinkercad online. This is a very good software that we have, which I usually use for my practicals for most of the technical courses. It's a simulator, it's an online simulator for Arduino, where we have the Arduino device itself. It has the components which will be as the inputs, which we call sensors, quite a number of them. It also has the components that we call actuators, which are usually the output. Then there's a breadboard which you can actually be able to use to connect those devices. If you want to use a breadboard. And this software, for us to be able to use it, you need to access the website, which is given by Tinkercad.com. Because I'm already registered, so it brings me to this point. Of course, I'll be accessing circuits, but if you are not registered, then what you need to do is to go to can be able to log out. And then so if you're not if you are not registered, then you need to go to join now, and then you create a personal account, and then from there you can sign up with email. So you can register now that mine is Kenya, so I do Kenya, and then of course the month of birth, I will be able to indicate mine as January 1st, 1975 year. Please make sure that you don't put under 18. For that case, then it requires that somebody enables you to access the website. Then after you do that, you just go to next. Then you can put your email address. So my at equat.ac.ke. You can put your password. And then create. So make sure you tick agree to the Tinkercad terms of service and the Autodesk privacy statement. So then you create your account. My account has now been created. So you can click on done. And it has welcomed me here. So I just close here. Then I go to circuits because this is what I am interested in. And I will go to create new circuits because this is a section which enables us to put together the sensors, the actuators, and also the Arduino microcontroller itself. So if you look at the right side of this simulator, you can be able to see that we have components here. So if you click on, but before clicking on that, if you scroll down, you can be able to see we have the basic components which are given by the resistor, the LED, the button switch, the potentiometer, there is the capacitor, the slide switch, the battery, a coil cell 3 volts, then it has 1.5 volts battery, a breadboard. We also have Arduino Uno. This is the main device that we will actually be using to control the inputs and the outputs. There's a vibration motor, a DC motor, a micro servo. Then there is a gear motor, there is the transistor, NPN transistor. We have the LED RGB, which means the 3 colors, red, green, and blue. And we have just a diode. So we have a photoresistor, ultrasonic sensor, distance sensor. Then we also have a PIR sensor. There's a piezo which will be used as the main output device also apart from the LED. Then we have a temperature sensor. And on this side, we have a multimeter, which you can be able to use. So mainly, if you go to all the components, you can actually be able to see general. And please note that general means that these devices are usually applied generally in the development of your circuits. A resistor will be used a lot when it comes to limiting the current through or to the devices that you want to connect to Arduino. One of them being the LED, which you need to connect a 220 ohm resistor to control the amount of current that's actually going in. A capacitor can be used to store energy, smoothing circuits, but in most of the applications we don't use it. Maybe the advanced ones, but the basic applications I usually don't use capacitors. Though we have 2 types, there's a polarized one and an unpolarized one. Then there is a diode, of course, which allows current to pass in one direction. Zener diode, this one, in most cases, will give us a constant output voltage. If you want to use it in your circuit, it can actually be able to regulate a voltage output. The inductor, which stores magnetic energy, can also be used in some cases. But mainly, as I've indicated, we'll be using a resistor a lot. Though at some point, when you are working with motor, you also require a transistor to control power. There's also the button switch, which will be used as our digital input, a potentiometer, which will be used as our analog input. There's a slide switch, you can switch on and off also. Of course, the push button means that you just, when you press, it will show as 1. When you have not pressed it, it will basically show as 0. Potentiometer, of course, will be giving us an analog input which ranges from 0 to 1023. Then there is a photoresistor for sensing light. We also have another type of light sensor we call a photodiode. Is basically just another diode which is developed in such a way that it can detect light energy. There is an ambient light sensor for environmental sensing, temperature as well. And then we also have an IR sensor. So the IR sensor is infrared sensor, ultrasonic distance sensor. So this one is basically a device that will be used to receive and transmit ultrasonic signals. This one has got 3 terminals. This has got 4 terminals, but they're supposed to be doing the same function. Then we have a PIR sensor, which is passive infrared sensor, which can also be used to sense infrared signal. And then when you scroll down, you can actually be able to see we have a tilt sensor. This for sensing tilting. When you tilt something, it will actually be able to sense the level. Then there is also another type. This is a two terminal. This would be a 4-pin one. And then we have a temperature sensor, of course, to change temperature to electric energy. Gas sensors will be changing gas energy to electrical energy as well. Then we have the keyboard, which will be, of course, our numeric. Then it's 4x4. Then we have the DIP switch, which has got also 4 terminals, just like the button switch. It has 4 terminals as well. Then we have the DIP switch times 4. This has got 4 in 1, and this has got 6 in 1. Those being the main input devices. The output devices for Tinkercad, which you can be able to access to connect to Arduino, are actually given by an LED, a light emitting diode. We have another type of LED, which has got, of course, the 3 colors, as I mentioned earlier, the red, green, and blue, where you can be able to mix those colors the way you want them to appear. And then there is a light bulb. There's a neo pixel, usually has got some lights which you can also be able to control. And all these are basically neo pixels, which are stripes of LEDs, where you can be able to control your lights if you are using them somewhere. So even this one also, the stripes, so this one's form rings, but this one's are just a stripe up to 20. And another type of device that you can actually be able to have to connect to the output is the vibration motor. Of course, this vibrates, is the one which you usually have in our phones. Then there's a DC motor. This will just rotate. It can be able to increase the speed, reduce the speed, or you can have it on and off. DC motor with an encoder, you can be able to encode this. You can also encode the second one, just similar. Then there's a micro servo, and also micro another type here. These ones can be able to move angles at given angles. It steps. It moves an angle. You can specify it to move particular angles. Like now, when you want to open something or you want to close, you can actually be able to use this type of motor. The gear motor, the gear motor, which of course you can be able to change the speed also. There's a piezo. This is our buzzer, one which you use to, of course, change the frequency and also the tone or the pitch of the output in terms of audio. So it usually allows us to change frequency or the pitch, which we sometimes call a tone. Then there's the IR, that's infrared remote control. We also have the 7-segment display. We just go to pause those 7 segments, and you can put them on and off accordingly to be able to display 0 to 9. Then there's the LCD 16 by 2. This will also be used to display like what you see usually on the screen after you read some value. You can be able to display it here before you use it. Apart from the serial mount, which you can also be able to see later, you can use to display your values. The power is provided by the 9-volt battery, 1.5-volt battery, a coin cell 3-volt battery. This is even if you want to maybe supply power to devices, we don't necessarily using the Arduino. Then you have to use those 3. So we have breadboards here, 3 of them. The main one, there's a small one, there's also a mini. The 3 of them will be used to expand our circuits because in most cases we want, if you want a case where your devices cannot just be connected to the Arduino, the space is not enough, then you need to expand using these breadboards. So they're usually important for expansion purposes when you are prototyping. Then the next one is So the next one is the Arduino microcontrollers. We have two of them. Or I mean the microcontrollers. We have two of them. Arduino Uno and also the Tiny. It's another microcontroller that we can be able to use also. The main one that we're going to apply is this one as we learn about these devices. Then instruments, you can have a multimeter, a power supply, function generator, oscilloscope. Sometimes you want to most probably measure current. You can measure voltage, you can measure power, you can actually use this. Power supply, if you want an external power supply besides the Arduino one, then you can use this one. And then function generator, you can be able to use this one to generate a signal of a given frequency, which can go into a given circuit that you want to see what's happening. An oscilloscope is also another device that we use to display waveforms. Integrated circuits, of course, there are quite a number, but usually interested in these ones that we have down here. Though, before you go maybe to those integrated circuits, there are power control devices. These transistors, where we have the NPN and PNP, but we also have the NMOS and PMOS. These are MOSFETs basically. The four types can be used to control power. And, those are the common ones that we can actually be able to use. Then we also have the edge bridge sometimes can be used to control the direction of the motor, the DC motors. Then there is the Wi-Fi module, which we basically use for Wi-Fi connections. This is for networking purposes. The ESP8266. Some connectors you require, you can use USB and also the 8-pin header, but we may not likely to use them. Logic, we have the ICs I was talking about. These are usually on logic gates. For logic implementations, you can be able to use these ones. And they are basically two input quad. But if we are talking about a NOT gate, is the one which is basically one input, one output. So this is an AND gate, 7400, an OR gate, 7402, AND gate, 7408, OR gate, 7432, XOR, 7486, X inverter, 7404, and those are the main ones that we usually apply. But if you want to use maybe flip-flops, which I also talk about, you can go for a JK flip-flop, 7473, a D flip-flop, which is 7474. And you also have a 4-bit binary counter. This is for counting. These are the main devices that you can actually be able to use in this Arduino, the ones I've indicated. So if we go through that, we have, or what I've talked about there is mainly the hardware part of these implementations, just basically the hardware part. And that's how they look like. So if you want to place the devices, this is what you do. If you want to place like Arduino, just go to basic. You can be able to access it very easily. Then you pick Arduino, you place it here. So if you want to pick a breadboard, you also pick this one, you place it here. Commonly, we shall be using the small one, but I will be showing you now how we use them. But this is just to pick the components you want to place. And then, if you want to pick the LED, you can just pick it and place it here. If you want to connect it, maybe somewhere, you can also connect it. But that will be the process of picking your hardware and putting it in the workspace so that you can be able to use it. So the other things maybe that we can be able to do, or which I will need to talk about, are the coding. And after coding, how you also do your simulations. But for the Arduino hardware, the components that we mainly use, these are the ones. So LED, you can have your button switch, that's how it appears. You can have your potentiometer, this is how it appears. Then you can have the PSO, because these are the ones which I use commonly. And this is also how it appears as well. So the other devices the same, so you pick them, you place them there in the workspace. But if you want them to do specific functions, then you need to connect them correctly. If you want to do a wire, so in most cases, you can just pick the wire. Like now, if I want the cathode, I connect it here. So you click on the device terminal, then if this is my ground, I just put it there. Please note that if I want to have corner like this, I click on the workspace. So if I want to connect an output, so I can also connect it this way. 3.3 volts. If you start this, by the way, it will just come on. So come on. Start simulation. You can see there it comes on, though it blows because it's a lot of current. If you don't want it to blow, then you connect it through a resistor, and you'll be able to see how a resistor becomes important here. So that's when you want to supply power to a resistor. I mean, diode, and I'm using 3.3 volts. So I can change this to 220 ohms. If I start the simulation, then you realize that the current that is going into that device is now enough. It is not blowing it actually, because I've applied a resistor. And this one is no control. I've just applied power to the platform. It's not of any functionality, but to show you how to connect the wires to the devices. And I think that can be enough introduction in terms of hardware that we are using in Arduino. Though at every point, when I'm using any kind of device, I need to, or these devices, you can actually discuss about them briefly, what they do, and then be able to connect accordingly. Thank you for listening to me.